Okay, so for example 2, where'd my pen go? For example 2, f of x equals 3x to the fourth minus 4x over x plus 3. What are the HAs? There are none, and here's why. So when you do the limit as x approaches infinity, okay, look at the highest power on top is 3x to the fourth. The highest power on bottom is x. What you end up with is just the limit as x approaches infinity of 3x to the third. And then you do your direct substitution, or you think of it as a right-handed disco curve, and that means it's going to be up to the right. Or just plug infinity in. Infinity cubes infinity, infinity times 3 is infinity. And anytime you get plus or minus infinity for the limit value, there is no HA. That means it's just going up or going down towards that end of the graph. So, and you can check it with negative infinity. It's going to be, the only difference is it's going to go to negative infinity, but that's irrelevant. So there is no HA. Now, it doesn't mean there's not an asymptote. It's just not the type of asymptote we're going to find. There are other asymptotes out there. We've looked at vertical and horizontal. There are what are called slant asymptotes. And it's actually not hard to find a slant asymptote if we wanted to. You actually just divide these two functions, and then whatever the remainder is the slant asymptote, which maybe I'll show you sometime. But that just means there's no HA. Okay, so no HA. Okay? Next example. F of x equals x over the square root of x squared plus 1. Is this going to matter? Yeah, you're actually going to have to approach both ends. Listen, why? Because when you look at this, you start with the limit as x approaches infinity, and you're like, okay, I'm just going to check the one at the right because I don't think it matters too much. And then you get x over, and then you deal with the square root of x squared. What is the square root of x squared? So immediately you should say, oh, wait a second, that's piecewise. I am going to have to consider both ends. If I'm going to infinity, what kind of x am I going to use? X or opposite of x? X, so it's going to be a ratio of coefficients and be 1. If I go to negative infinity, what am I going to use? If I go to negative infinity, when I look at the absolute value of x, I'm going to use the opposite of x, so it'll end up being negative 1. So this graph has two horizontal asymptotes. One is at 1, and the other one is at negative 1. Now, go to your book, okay? Let's look at one with the calculator. So the homework last night, everybody got the homework out? I'm not checking it today, it was a little different. So go to the book, and I want everybody to look at number 3. Everybody look at problem 3. I did number 1. 1's a video on Moodle, so if you want to look at 1, you can. If you look at number 3 right now, e to the negative x over x. E to the negative x over x. Okay? Go ahead and graph it. And I'm going to show you why this one's a little bit confusing and why, when you're doing your calculator, it is really important, I think, to, and I'm going to bring my calculator up just because I think this one's weird enough. Then we're going to do one more without the calculator, or confirm it with the calculator and alphabet. Sometimes you just can't do it by hand. Sometimes it's really difficult. I mean, I'm not saying you can, I'm just saying it's more difficult to do by hand. I mean, you technically could think about this one, and I think we can talk about it a little bit, how we can think about it numerically. So let's go ahead and go to y equals. So everybody go to y equals and type in your equation. I'm going to have to do something here, though. Turn that off. Good. Clear this out. Come on. Why is it being so slow? All right, so I've got this. What am I typing in? Okay, so I'm going to go second. ln. Yeah, I'm just doing power. It's okay. You can, but I don't think you need them. My thing is running so slow right now.
Yeah, buttons are falling off.
I'm losing memory. I think I know where my buttons are. Are you serious? Right now. hello. Hey. Yep. End of the hour, Amy, go to the office. So once I get this, here's what you're going to see. So when I'm going to press Zoom 6. And I'm going to graph it. I always like to graph it first. That's just me. Okay, I think it's a good idea to graph it first. Let me do something right quick, y'all. And mine, you're going to see it. I think you can see it a little bit better on mine. It's not much running. Shouldn't be using that much memory. And if I look at the tails, you can see from the graph, it seems like there's a horizontal asymptote at what? 0, because of which tail? The right one. The right tail, the limit as x approaches infinity, it looks like it's approaching 0, and I'm pretty convinced it is. The left tail looks like what? It's going down to negative infinity. So there's one horizontal asymptote because of your right tail. Now, if you go to the table, I just wanted to review this. When you do the table, you're going to go press second window. Okay, so you'll press second window, and table start. Whenever I'm approaching positive or negative infinity, I just start my table at 0. Now, if you go to 10,000 like I told you, you're going to run into a problem here. And that's what I need to talk about, because you can't, approaching positive and negative infinity sometimes can be a little weird. Even if you approach 1,000, it's going to be a little weird. I'll do 10,000 just because that's probably what most of you do. And if I press second graph, you're going to get the table, and you're automatically going to see the right goes to 0. And you're actually going to be maybe convinced that it actually gets to 0. But I'm here to tell you it will never get to 0. It will get close to 0, but it will not hit 0. Okay? Because the top is what? Top is e to the negative x. Can e to the negative x ever equal 0? No, I mean, I don't know about you, but e to the negative x is, if I was to try and take the top of this thing and set it equal to 0, try and solve that equation. First of all, does the L curve ever touch the x-axis? No, for my graph, I should know this is not true. But if you try and solve this, try and take the ln of both sides. What happens? You're not taking the ln of 0. Can you take the ln of 0? Absolutely not. So that's why that's not true. Okay, so I know this can't equal 0, so why on my calculator, when I scroll down 1 and go to the right and go there, because it should show me decimals there. Why does it not show me decimals? Because it's so darn close, your calculator cannot even compute it. The calculator ability to compute how close it is to 0 is limited. Let me prove to you that it's limited. Go back to your table, set, and change that to 100, your delta table. Instead of going up, because it's getting close to 0 so fast, you don't need to go very far to see what happened. Change that to 0, or 100, sorry. Come on, calculator, keep up with me. Go back to the table, and you will see, look at it, 100 is 4e negative 46. That's already 46 decimal places. That means 45 decimals, 45 zeros in front of that 4. And then it goes 7e negative 90. It even it like doubles the decimal values almost. Okay? And so you're like, so then what happens? Your calculator loses the ability to compute it. So you're just like, okay, it's approaching 0. I'm convinced. All right? It's just going really fast to 0. If you look at the other side, you'll kind of see a similar situation. What happens is on the other side, it gets big, it gets infinitely small so quick. And what I mean by infinitely small, it's going towards negative infinity so fast, the number gets so big the calculator can't handle it. So you're convinced, like negative 3e41, that's negative 3 with 41 zeros behind it. Negative 4e84, that's a negative 4 with 84 zeros behind it. I mean, that's a huge number. I want that in my bank account.
Is there an error?
Because the calculator can't compute it again. It's too big. It's too infinitely small. Well, sorry, yeah, I don't want negative numbers in my bank account. Sorry, I want the positive one. Okay, you get it though? And I think most of you could have confirmed that with the graph anyways. But I at least wanted you to see. Okay? Now, let's do one more, just for kicks and giggles. My calculator's like, I don't know, it's got problems today. Look at number 6, and I want you to graph number 6 real quick, and let's talk about, just quickly, on number 6 in the book, and then we'll go on to VAs, and then we'll finish with the squeeze there. I think it was number 6 in the book. It says the f of x equals 2x minus 1. Absolute of x minus 3.
Ooh, is that where there might be like slant?
No, this one is actually pretty straightforward. It's almost like example 3. Because, go ahead and graph it. You got 2x minus 1. You will need parentheses on this one. You will need parentheses around the 2x minus 1. You'll need parentheses around the absolute value of x minus 3, or it's not going to graph right. Okay, so make sure you get parentheses around it. Did everybody see it? Okay, I think you got something that looks like this. Can everybody see Jake's? And you will see that it looks like it's approaching what at both ends? You kind of have to guess. What would you say?
2 and negative 2?
I think 2 and negative 2. But it's hard to see from the calculator, right? Like, you would definitely want to do what on this one? You would want to check the table on this one. And if you went second table setup, set it at 0, and went to 10,000 or 1,000 or 100,000 or whatever you want, you probably see it at both ends is going to 2 and negative 2. Now, watch with my hand how you do this. You do need to check both tails, and the reason you need to check both tails is because it's dumb absolute value. So you're going to have to do the limit as x approaches infinity. Largest power on top is 2x, largest power on bottom is absolute value of x. As I go to infinity, it'll just be 2x over x, which will be what? 2. Is it easier without the calculator on this one? That's what I'm trying to argue here. Sometimes the calculator's good, sometimes the calculator's necessary. The last problem, I think the calculator is a little bit more necessary. This one is probably better just to do it by hand. It's probably faster. Okay? So we kind of identify those times when I say all techniques. Figure out the technique you think is going to work best. It is possible to think about the last problem. I want you to go back to that e to the. Before I go and do vertical asymptotes, you know that e to the negative x over x problem we just did? It is possible to think about what would happen as x is approaching infinity. Like, as x approaches infinity, like, seriously, you could think about this one. As x approaches infinity, you could be like, okay, e to the negative x. How does that behave as x approaches infinity? Well, I know that's a what kind of curve? L curve. What does this approach, the top approach, as x approaches infinity? Look at your L curve. What does it approach?
0.
I think the top approach is 0. And then you get the bottom is infinity, but the problem is a lot of times we go 0 over infinity. Should we say it's 0? Really, we shouldn't say for sure it's 0 without evidence, but if I take 0 and I just keep dividing by numbers all the way forever, is it still going to be 0? 0 divided anything is 0. So we can kind of see where we think algebraically this is going to work out to 0, but I'm going to go ahead and tell you this does not always work. Okay? So this is not a safe way to do it. You can kind of think about what you think is going to happen, but it's definitely a lot better to look at the graph. Same thing as if you let it go to negative infinity. If you let it go to negative infinity, you're going to say, well, this is going to infinity. And then what you get is a situation that's really weird. If you go to negative infinity, you're going to say, well, the top's going to infinity, and the bottom's going to negative infinity. How do you deal with that? Once infinity divided by negative infinity, a lot of people would want to say negative 1, and that's not correct, because we already looked at the graph and we saw that it approached negative infinity. So it doesn't always work, is what I'm saying. So sometimes those kind of problems you have to really look at the graph and table. So that problem was more necessary to look at the graph and table, where that problem number 6 wasn't with the absolute value. It was faster by hand than it was easy to do by hand. Okay, we did vertical asymptotes yesterday with you guys, so I'm not going to have to read through as much of this as I did the other class, because they didn't go through this up at the top. So go back up to the top just a second. We made it through this in class yesterday, vertical asymptote. And we essentially said a vertical asymptote is an undefined value, right? And we know it's a vertical asymptote because whatever that vertical asymptote is, if we say it's 2, as you approach 2 from the right or left, what's going to happen? It's either going to go to what? infinity or negative infinity. That's what a vertical asymptote is. And we also concluded, said, hey, if it's just 0 on bottom, that's going to be the situation where we get a vertical asymptote. If it's 0 on top and bottom, what's that? A hole. So let me go through 3 examples with you real quick here, and then we'll go to the squeeze theorem. So we went through those notes yesterday, and the next 3 examples, find the vertical asymptotes and describe the behavior to the end. Describe the behavior to the left and right of each vertical asymptote. Okay? Now, one of these problems up here, if you look at it, okay, has I've got 3 situations up here. I've got a situation where you have 1 VA. Okay? I've also got a situation where you've got I've got a situation where you got 2 VAs. I've got a situation where you've got an infinite number of VAs, and I've got a situation where you have no VAs. Okay? So this, I want to go ahead and tell you, you need to be able to do it without a calculator. So go ahead and just put the calculator away. You don't need it now. Okay? Let's take a look at this first one. F of x equals negative 2x over x squared minus 4. How would you go about finding the VAs here? Let's kind of reiterate what we said yesterday. What do you do to find a VA?
You're gonna find
Is it whatever the limit equals?
there's 1 0 on the bottom.
That's where horizontal is where the limit is x approaches positive negative
1
infinity.
0 on the denominator.
All right, you want to see when you're doing a VA, you're looking for where just the bottom equals what? Not bottom and top. So let me go ahead and tell you, the best thing you can do is see if the fraction simplifies first. The absolute best thing you can do is see if the fraction simplifies first, because if it does simplify, you're going to get rid of the holes. You see what I'm saying? If you can simplify it, you'll get rid of the holes, and you won't mistake those for a vertical asymptote. Does this first one simplify at all? No. So now let's just set the denominator equal to what? 0. What are we going to get when we set the denominator equal to 0? Plus or minus 2. That's it. That's your VAs. That's how easy it is. You are done. Your VAs are plus or minus 2. All you had to do is figure out where the denominator equals 0. Now, the directions say to do something else. It says find the vertical asymptotes and describe the behavior to the left and right of each vertical asymptote. So we're just going to do this we're not going to do every one, but we'll do this one. Limit as x approaches 2 from the right. And I'm not going to do both of them because let's just do one of them just to kind of make the point. This is on your quiz tomorrow, so this will be really healthy to pay attention to. All right? So I'm checking one of the VAs. The directions say to check both. But are you okay with me just checking one of the VAs?
Yeah.
We know what should happen. I'm just trying to show what's supposed to happen. What's supposed to happen as we approach 2 or negative 2 from the left to right? It should approach infinity or negative infinity. And remember, the definition says it just has to be one or the other. It doesn't have to be both sides. We have some graphs where it only approaches an asymptote from one side. I'll give you one example right off the top of my head, a log graph. The log graph has a vertical asymptote, and it only approaches a vertical asymptote from one side. Piecewise functions. In fact, piecewise functions are really confusing because I'm going to give you a piecewise function later this year where it approaches an asymptote from one side. So you got an asymptote there, right? Now I'm going to do this. You're going to get mad at me because you're going to say, a vertical asymptote. Wait a second, you said a function can never cross a vertical asymptote. The only time it can cross a vertical asymptote is when it's what kind of a function? Piecewise. I forced it to cross that vertical asymptote. It wouldn't have crossed it. It wouldn't have crossed it on its own. Okay? I had to force it to cross that vertical asymptote. All right? So I have a vertical asymptote on one side. You only need it to happen on one side. It can happen on both, and it's great. Somebody said, well, what happens if it's both? Awesome. Okay? We're just going to see to make sure it definitely happens on one or the other, because that's what classifies it as a vertical asymptote. So 2 from the right. Let's do this, because it's on the quiz tomorrow. So you got negative 2x over x squared minus 4. How did I tell you to go about this? This is where you want to say, okay, if I plug in 2 right now, you're going to get what in the denominator? But you don't get 0 on top, so there's no algebra you can do. So what do you do then? You go to 2.1. Now the top, you can just go ahead and let it approach 2, because you're not going to get 0. So I can just go ahead and plug 2 in on the top. The top's going to approach what? Negative 4. So that's not a problem. It's the bottom. The bottom, I can't put 0 on the bottom, so what I need to do is numerically think about what's happening as I get closer to 0. So if I plug 2 in, 2 from the right is 2.1. Is that going to be bigger than 4 or less than 4? So we're going to get small positive decimals. So what's negative divided by small positive? negative infinity. So that right there guarantees you that positive 2 is a VA. You don't even need to check the other side, but we're going to.
How come you don't need to? Because what if
Because by definition, a vertical asymptote, it only has to be either or. It only needs to approach positive or negative infinity from one side. Both sides, great. Huh? Well, I'm not doing VAs and HAs tomorrow. Tomorrow you're just doing limits. So I'm just going to have to drop it for you. But yes, you can be guaranteed I'm going to have you do both sides at some point. Even though it's not a very long quiz. All right, negative 2x over x squared minus 4. Let's do from the left. Well, again, the top you can just do it's negative 4. All right, 2 from the left. What's 2 from the left? 1.9. Now, if I put 1.9 in here, small negative, so small negative decimal, so what is that going to be? Negative divided by negative is a positive infinity. And if you check the graph, I promise you that's what you're going to see.
Would you have to check the negative? Would you have to check the negative too? Like,
I would, but I'm not going to do that one.
I'm just saying, like, you wouldn't have to choose both plus or from the left or right to get to approach negative 2 by positive 2. To show.
Well, I verified that 2 is a vertical
You
asymptote.
have to verify that.
Now I'd have to go and do the same thing for negative 2 and check it from the left and right. But I'm just going to do one of them. We just checked one VA. We didn't check both VAs. Does everybody understand? We just checked the VA at positive 2. You'd have to go back and check the VA at negative 2, which I did not do. Now, I could ask a further question here tomorrow on the quiz. What would the limit as x approaches 2 of this be? D and E. Why? Because the limit from the left and the limit from the right do not what? Agree. Okay? The next one right here, tangent. It's a little more interesting. It's going to be sine over cosine. If you watched my vid last night, you would know how to do this. But if I'm going to do this one, again, there's no algebra you can do here. You can't cancel anything out. You can't cancel sine and cosine out. If I did, that would destroy all the trig we've done all year. Okay? But I can set the denominator equal to what? Set the denominator equal to what? Find the VAs. Guys, all you do to find a VA is after you simplify the fraction, set the denominator equal to 0. That's it. Set the denominator equal to 0. Figure out where it equals 0. Those are your VAs. Now, I did this one on purpose because I wanted to review. How do you solve this? Inverse trig. We're going to have to do inverse cosine. So I'm going to do inverse cosine of 0, which means I got to think backwards on the unit circle. So where does cosine equal 0?
pi over 4. Pi over 2.
Pi over 2.
Pi over 2, yep. Pi over 2 it equals 0. Where else? But since I didn't have any restrictions,
That's all.
it's every angle that's also coterminal with pi over 2 and 3 pi over 2. So how can I write something down?
X equals pi over 2
plus pi k.
Yeah, I can just do x equals pi over 2 plus pi k. Oops. Okay? That's it. That's all your VAs. Now, somebody's going to say, do you want us to verify every VA? No, because we'd have to do that to the end of time. Okay? And I just want to do that if I want to punish you. All right? So I'm just going to check one. I'm going to check pi over 2. So let's check pi over 2. Limit as x approaches pi over 2 from the right. So you have to check. You want to check both sides. It says to. Check from the left and right. X approaches pi over 2 from the left. Okay, and I'm going to do sine x over cosine x. All right, let's start with the right. Let's see what it does. Now, if you watch my video, I actually did a problem like this, and I did it numerically, and I graphed it to verify that I was right. So pi over 2 to the right. Give me pi over 2 to the right. Pi over 2 is 1.57. So what would be pi over 2 to the right?
5, 6.
To the right. 1.58. Don't look at your unit circles because that'll confuse you.
Okay.
I just want a number bigger than 1.57. So what's 1.57? Be 1.58. Now, if you go to the top, you can just plug in pi over 2 because you're not going to get 0 there. Sine of pi over 2 is just what? 1. Well, when you plug in 1.58 here, because you can't plug pi over 2 in here because you get 0. So I'm going to go to 1.58. 1.58 is in what quadrant? Quadrant 2, which means cosine is what? Yeah. Quadrant 2, which cosine is what? Small negative. So that means this goes to what? Infinity. Down here, pi over 2 to the left, what's pi over 2 to the left of it, 1.56. So the top's going to 1. The bottom, if you go cosine of 1.56, which puts you in quadrant 1, small positive, what do you get? Positive infinity.
So the graph look like.
Well, think about your tangent graph. I do it on the thing. It's pi over 2. Remember, there's an asymptote there. There's a point here. Looks like this, right? And that agrees with what we got. Pi over 2 to the right, negative infinity, pi over 2 to the left. Example 3, I typoed. I did a typo. It's supposed to be, and I did this specifically to get you ready for your quiz tomorrow. It's supposed to be x to the third. So talk to me. Talk to me. How are you going to do this one to find the VAs? I said you should do what first to make sure. See if you can do any algebra to cancel anything, because if you can't cancel something, then that's a hole, not an asymptote. Can you do any factoring? How does the bottom factor? Oh, yeah. Come on. They got it. They nailed it.
X minus 2.
X minus 2. Good. You got that part. Cube root of each. X squared plus 2x.
Minus.
No, it's minus plus plus. Plus 4. What happens to x minus 2's? Gone. Now you're like interested in this part. So you're like, okay, VAs, whatever that equals 0. I got news for you. It's never going to equal 0. And I've told you that before. And you don't remember. So if you know your sum of cubes and difference 2 cubes formula, a cubed plus b cubed, a cubed minus b cubed, it's a minus b, a plus b, that part, you know. And then the a minus b goes minus plus plus, and it's a squared plus ab plus b squared. The other one's a squared minus ab plus b squared. What happens, you end up getting, if you take that trinomial, as long as it's reduced into a squared, if it's not squared, if it's a fourth, it probably can factor further. But, let me say this about it. If it is reduced into squares, it's always imaginary. And you can prove that with quadratic formula, which I did do for you a month and a half ago, but you forgot. Okay? If you don't believe me, take a squared plus ab plus b squared, take 1, 1, 1. Your coefficient's 1, 1, 1. Run it through quadratic formula and see what happens. Take your coefficients 1, negative 1, 1. Run it through quadratic formula, see what happens. And then you've proved it for all cases. Somebody would say, well, that's not a 1, 1, 1. That's a 1, 2, 4. I promise you, because it fits that pattern, it has to still agree with that proof that I've already done, which shows that they're already going to be imaginary. You don't believe me? Take 1, 2, 4. Just run it through the discriminant part. You know, the b squared minus 4a squared. If that's negative, you know it's imaginary, right? Is that the part in the quadratic formula that matters for imaginary? That's the part under the square root of the quadratic formula, right? If that guy's negative, b squared minus 4ac is negative, it is negative, isn't it? So, here's the thing. When you do sum or do difference of 2 cubes and this part cancels and you're left with this part, you never have to worry about this part equaling 0, because it never will. Also, if you graph this, if you were to graph this equation, you will not see it cross the x-axis, which is another verification that it doesn't equal 0. Okay? So, what do you put then? You put no VAs. There are no vertical asymptotes. There was only a hole on this graph. Okay? Holy cow. All right, squeeze theorem. Squeeze the life out of you. Squeeze theorem. I actually had a little bit more time to explain this to you guys, but I'm going to make you do something for me tonight, and then we're going to go back and finish up squeeze theorem tomorrow in your continuity stuff. Okay? So, let's squeeze theorem. Go to page, it's on page 67 in your book. 65 or 67, let's see where it's at. It's page 65. And the reason the sandwich theorem was invented is because here's what I'm going to have you do tonight. I'm going to make you, you're going to memorize 2 special limits. There are 2 special limits. You need to memorize. And the first one is this: the limit as x approaches 0 of sine x over x. This guy is special. I don't know what it is right now. I do. You don't know what it is right now. Tonight you're going to take your calculator and figure out what it is. It'll take you about 10 seconds to do, 20 seconds to do tonight. Come back tomorrow with what that equals. Do not tell me right now. I don't want to know right now. The other one is the limit as x approaches 0 of 1 minus cosine x over x. Let me tell you why the squeeze theorem even exists. You don't have to prove the squeeze theorem in this class. You don't have to do a proof on the AP exam of the squeeze theorem. But you need to use some things that have been proved by the squeeze theorem to do some other stuff. Let me explain what the squeeze theorem is, and this is about the only thing you have to do it. Okay? And then just memorize these two facts. The squeeze theorem, and you'll use this way more in like Calc 2 and Calc 3 if you go further. Okay? The squeeze theorem says this. If I have some functions that I can't find the limit of, look at this one. The limit as x approaches 0 sine x over x. Try direct substitution and tell me why it doesn't work. You're going to get 0 on the denominator. But then you plug it on top and you're like, okay, sine of 0 is what though? So you get 0 over 0. Well, Mr. Morris said that if I get 0 over 0, there's got to be some algebra we can do. But here's the problem. When you run into a lot of trig things, there isn't algebra you can do. There is no algebra you can do from this problem. It doesn't exist. You can't figure out what sine x over x is by trying to cancel something. Some of you are like, well, can I just cancel the x's out? No, that's like I said that time before. Sine x over n doesn't equal 6. Okay? Can't cancel the n's out, make it equal 6. So I can't cancel the x's out there. All right? So how do you do this problem? It was proved from the squeeze theorem. The same thing over here. If you put 0 in the denominator here, you're going to get 0. If you put 0 here, you're going to get cosine of 0 is 1. 1 minus 1 is 0. You get 0 over 0, but there's no algebra you can do. So these two limits right here are proved by the squeeze theorem. Let me show you what they are. Okay? I got like 4 minutes, guys. Quit cutting me off. All right. It's on page 65. Everybody needs to look at it with me because you will not see it if you do not look at it. Okay? Anybody not looking at it can hang out with me and lunch. Good. Page 65. All right? There's a lot of limits you can't find directly with algebra. All right? So what they do is you can find it indirectly with the sandwich or squeeze theorem. The theorem refers to a function f whose values are sandwiched between two other functions, g and h. If g and h have the same limit as x approaches c, then f has to have that limit too, as suggested in figure 2.7. So everybody look at figure 2.7. You see function f. It's a really squiggly looking thing. It's probably got some trig in it. And at c, you can't find the limit because it's undefined there. Because you get 0 in the denominator for some reason. Okay, so there's a hole there. Because you get 0 over 0 actually. So what you do is you pick a function that's bigger than f, and you pick a function that's smaller than c that will meet at that hole. And what happened is you squeeze that function that's between those two functions. So once you pick one bigger and once you pick one smaller, if the function on top and the function on bottom will both meet at that hole, then it goes to show that if the limit of this one is a certain value and the limit of this one is a certain value, and if those two values are equal, then f has to take on that value. That's all it shows. So if you're looking at that, if h, does everybody look at h? Does it look like h is going to have the same limit as g? According to that picture there? That they're both f, that h and g are both approaching that hole? But here's the difference. The way we chose h and g, the limit actually works. You can do algebra with those two. So we chose h and g where there wasn't a hole. But we're making it hit right at that hole, and what happens is now f, if h and g have a limit equal to that hole.
You just set them equal to each other then?
Essentially, you have to set up some kind of an inequality, and that's why it says here, if g of x is less than or equal to f of x, which is less than or h of x, in other words, if f of x is between g and h, for all x except c, in some interval about c, then if the limit of x approaches c of g of x is equal to the limit as x approaches c of h of x, which is L, then f of x has to take on the same limit value. That's what the squeeze theorem is. So when you hear them talk about the squeeze theorem, they proved these limits that we're going to find tonight. You're going to use a calculator. You're not going to prove them with the squeeze theorem because it's too hard for you to do, and I can barely do it. Okay? I know how to do it, and I can look at it. I couldn't come up with it on my own. I understand the proof. When I look at the proof, I'll show it to you tomorrow. And you're like, I get it. I just would never think to do that. And that's exactly the same shoes that I feel like I'm in. So I would never be able to come up with it on my own. So some smart guys figure this out using the squeeze theorem. What I want you to do is, since you can't do it with the squeeze theorem, I want you to use your calculator to get the answers tonight. and then I'll show you how it's done with the squeeze through. Okay? Your homework tonight is on Moodle. It's a review. It's called Infinite Limits. It's just a review of limits as x approaches infinity and doing some stuff with vertical asymptotes where you check from left and right. It's 1 through 44, and it's just going to help you get ready for quiz tomorrow. You will need a calculator some tonight.